you know what like terms are and how to simplify polynomials. So like terms is terms that have exactly the same variables raised to exactly the same exponent. So for example, 3x squared, negative x squared, and 7x squared are all like terms because they all have x squared. Okay? They're all like terms. Now the distributive property is the property where I have a number on the outside of a bracket and I multiply that number into the binomial. So we did this yesterday. So for example, let's use an example. So I have 9 times x plus 3. Who can tell me what that simplifies into if I were to distribute it into the bracket? Olivia. Yep. 9x plus 27. So I'm taking my letter a, or my variable a, and multiplying it by b, and then multiplying it by c as well. Do you guys remember how to FOIL?
Yes.
Okay. So let's say I have my two brackets here. I'm going to multiply my first in the inner by my first in the second bracket. So I'm going to get a times c plus, and I take that a and multiply it by the last term in the second bracket. So it's a times d. Then I'm going to take my second term in the first bracket, multiply by the first term in the second bracket, which is bc, and then b times d. So that gives me plus bd. So an example of this would be, let's say I have x plus 4 times x plus 3. So we're going to FOIL this using our distributive property. So we're going to always start with my first term in the first bracket and multiply by every term in the second bracket. So what's my first half of that simplifying going to look like? What's x multiplied by x? So we got x squared. What's 3 times x? 3x. And now we start with my last term in the first bracket and multiply by everything in the second bracket. So 4 times x gives me 4x. And what's my last term going to be? 12. Do I have any like terms? Okay, what are my like terms? Yep. And when I add those together, what does that simplify into? 3x plus 4x. 7x. Plus 7x plus 12. So this would be my final answer. Yep. No. So whenever you're adding like terms, you leave the variable part the way it is. So you leave x as x and just add the numbers together. So now let's move on to just a quick example. So we'll do example B. We'll do every other one because I think this is going to take way too long to do all of them. So I have 3x squared minus 2x minus 4 minus x squared plus x minus 5. So whenever I have a negative outside of the brackets, what happens to everything inside the bracket? So if I have this negative on the outside and it goes inside my bracket, what happens to all of those signs? They switch. Okay. So my negatives become positive and my positive become negative. So I get 3x squared minus 2x minus 4. Because my x squared is positive, it now becomes negative x squared. My x is positive, it becomes negative x. And because my 5 in front of it is negative, it becomes positive 5. Now, what do I have to do next? Olivia? Collect like terms. So when you collect like terms, you can either underline them in different colors or just literally collect them and put them beside each other. So I'll do it both ways. So my first like term is 3x squared and minus x squared. What's my next set of like terms? Olivia? Yep. Yep. I get minus 2x minus x. And last but not least was my last pair of like terms. Brooklyn. Yep. Perfect. So like I said, you can do it the way I'm doing it. So you can either underline or you can group them together like I'm doing. So option 1 or option 2 doesn't matter. Whatever works for you, you're going to get the same answer regardless. So 3x squared minus x squared, what does that simplify into? Yep, 2x squared. Minus 2x minus x, negative 3x. And what's negative 4 plus 5? Brooklyn, 1. So my simplified expression is 2x squared minus 3x plus 1. When you have two brackets of this percentage. Otherwise, you just. Yep. So for this one, we did not have to FOIL because we do not have two binomials being multiplied by each other. Yep. So if it's a positive, you just keep everything the way it is. Okay, so for C, I have two binomials being multiplied by each other. So for C, I have 3x plus 1 times 2x minus 3. If I go down, it's too far down. Ooh, okay. So what method am I going to use to simplify this expression? Olivia, we're going to FOIL. So again, my 3x multiplied by my first two terms. And then at the end, take my 1 and multiply it by the two terms again. So who can tell me what the first half is going to look like? Nope. Ashton? So 3x times 2x is 6x squared. Okay, what's the next term, Ashton? Minus 9x. And can someone tell me the other half of it? Brooklyn? You're taking the 1 and multiplying it to 2x and negative 3.
So it would be 2x.
Mm-hmm.
Negative 3.
Yeah. So now what is my only pair of like terms? Cynthia?
Negative 9.
Yep, so what does that simplify to? Positive or negative, Omer? Nope, look at the 9. What's in front of the 9? So it's going to be negative 7x. And then minus 3. Whenever you're multiplying two binomials together, your like term is always going to be the two terms in the middle. So as you saw in the first example up here, it was 3x and 4x. If you look at this example here, it's negative 9x and 2x. So when you're multiplying two binomials together, your like terms are always going to be in the middle. So my simplified expression is x squared minus 7x minus 3. Yeah, we're going to do it together. Any questions about this so far? Or is it pretty straightforward for now? Okay. So let's move on to D. So D, I have negative 2 times x minus 2 times 2x plus 1. So there are two ways of doing this. Okay. I want to see which way you guys would start this problem. Would you want to FOIL first and then distribute, or distribute first and then FOIL? Sure. Okay, we'll distribute first. That's fine. I like doing the hard stuff first and then the easy stuff at the end. So what's harder, distributing or foiling? You say both? Okay, so let's look at our definition. What requires more work? Distributing means you have one number on the outside and you're multiplying it by everything on the inside. So which one takes more work? Foil. So we'll do the hard part first to get rid of it. And then that way at the end, you guys are just focusing on distributing. So we will leave this until the end. Or not. If you choose to do it at the beginning, that's fine. No, because you'll end up getting the same answer regardless. So whatever you guys feel most comfortable with. So we'll do the annoying stuff first. So we'll do the foiling. So we'll leave our negative 2 as is. We're not going to touch it yet. So when I FOIL my binomials together, what am I going to get? So what's the first half going to be?
2x squared.
Yep, 2x squared. Okay, what's my next term? Plus x. Perfect. And then what happens after? Negative 4 what? Negative 4x. And then? Negative 2. Okay. And as you can see, again, my like terms are in the middle. So what does my bracket simplify into? So what's x minus 4x?
Negative 3x.
Yep, minus 3x, minus 2. And now I can distribute my negative 2. Okay, now that we've done our annoying part first, I can now distribute my negative 2. So what's negative 2 times 2x squared? Negative 4x squared. Negative 2 times negative 3x, positive 6x. And negative 2 times negative 2, positive 4. So my simplified expression becomes negative 4x squared plus 6x plus 4. Any questions?
Wait, so whichever way you do the, like if you foil first or if you like extend this, it's gonna be the same.
It's the same answer.
Okay.
It's just I don't like doing foiling at the end because I'd rather do it at the beginning. Okay, so any extra questions before I move on? No? Okay. Oh, the fraction one? Yeah, why not? All right, so let's move on to, yeah. Okay. Okay, let's do E first.
Why is the 2 brackets?
Because it's allowed to be 4 brackets. All right, so listen up. So for E, I have x plus 1 times x minus 2 minus x minus 3 times x plus 2. Yes, Emma?
So when we foil the first one, the foil the second one, and then do it all together?
Yep. So we're going to FOIL the first one. Okay. So when I FOIL my first set of brackets, what do I get? Yep. Keep going.
Minus 2x squared. No, minus 2x.
Yep.
Then 1x.
Yep.
X. Then -2.
Yep. -2. Perfect. So then I have minus, and then I can factor my next set of brackets. Okay. Yep. Keep going, Jade. X times 2.
2x.
Yep.
Plus 2x.
Yep. The second foiling.
-3.
Yep. Good.
And then -6.
Perfect. There we go. And -6. Yep.
Why did you pick the brackets for this second one?
Because I have my, so if you notice here, there's a positive in front, so which means all my signs stay the same. However, there's a negative up here, which means I have to do this first and then worry about it after. Because the negative, remember, changes everything in the bracket. So what's my like term in my first foiling set? X squared minus 2x plus x minus 2. What's my like terms? Olivia?
X squared minus x minus.
Yep. So I get x squared minus x minus 2. Now my like terms in the bracket are 2x and -3x. So what does that simplify into? 2x minus 3x. What's 2 minus 3? Negative x. Yep. So negative x minus 6. And now, what does this negative do to everything in my bracket? It changes the sign. Okay? So my positives become negatives and my negatives become positives.
Why does that change?
Because I'm multiplying by a negative. That's why.
Okay.
So I got x squared minus x minus 2 minus x squared plus x plus 6.
You would remove the bracket?
Yeah, you would remove the bracket. So now, what are my like terms in this case? Cynthia?
X squared
Mhm.
and -x.
Okay, what's x squared minus x squared? 0. So you can cross these guys out. What's my next pair of like terms? And what does that give me?
0.
0. And what's my last pair of like terms?
-2. 6.
Yep, and what does that give me? 4. So this whole thing just gave me 4.
I'm kind of disappointed, sir.
Me too.
Yeah.
I'll make it my duty to give you guys simplifying, and it just gives you an answer of 1.
No, I get it. I get it.
Yep. The plan.
I get it. I just
Okay. So does everyone understand the steps in foiling? Okay.
I'm just kidding. Actually, I'm very confused.
So now F has like 4 sets of brackets, so gotta be careful with F. So make sure you copy down E, and then I'll move on to F.
I'm dying.
Why? Oh shoot, I have some signatures for.
It's probably gonna become serious.
Is everyone good, or do you need more time to copy down?
I'm dying.
1 second? Okay.
Because they haven't granted like that. X squared minus x squared. Okay. So they can.
so confused.
Okay.
How did you just do this?
So the next one I have is 2 times 3 times 2x plus 3 times 2 times x minus 1.
So why is this square brackets and why is it regular brackets?
So the square brackets means I have multiplication in my main bracket. So in order to not have two sets of round brackets, that square bracket is there. It's just a notation thing. If you were to write it like this, I would be fine with that. Because what this is saying is that 2 is being multiplied by whatever I get in here.
So you would solve in the square bracket first,
Mhm.
or the circle bracket?
So you would do everything. So this is what you would
The
do.
square bracket, then the circle bracket.
The square bracket comes after.
Circle
So
bracket,
you
then
would
the
do.
square bracket.
So you would take your
So you do
3.
2x plus 3 and then x minus 1, solve for that.
Mhm.
But there's nothing to solve for.
No.
So then we just do the square brackets, so it would be 3 and then the FOIL.
So what you're gonna do first is you're gonna take
Is that
the
right?
close.
Dang it.
What you're gonna do is you're gonna take your numbers in front of your circle bracket and you're gonna distribute it into your bracket.
But you can also do it vice versa.
No, I would not. I would not do this first. This you would always leave last.
That's more complicated.
Yep.
No, I meant like how last time we did we foiled it and then distributed.
Well, we don't have to foil here because we're not multiplying two brackets with each other. So if I distribute my 3 into 2x plus 3, what does that become? Lisa. Okay. Plus 6x plus 9. All right. Now if I distribute my negative 2 into x minus 1, what do I get? Negative 2x plus 2. So I'm left with 6x plus 9 minus 2x plus 2. So what are my like terms in my square bracket? Okay. Okay, so what does that give me? 4x. And my last pair is going to be 9 and 2. What's 9 plus 2? Yep. 11.
Okay, wait, so now we solve the square bracket.
Yeah. Now I'm gonna take my 2 that is outside of the whole bracket, and I'm gonna distribute it into 4x plus 11.
So it would be 8x plus 22.
Yep. Shh. What's up? Mhm. So when I distribute my 2 into 4x plus 11, what do I get?
8x plus.
Yep, 8x plus 22. And that would be your expression.
I'm gonna forget how to do this. Why did you
Guys, I can't hear Maria. I can't hear Maria. She's asking a question. Because I multiplied it by negative 2. That's why. Okay. I'm going to give you guys some time to do G on your own. So do G on your own, and then I'll come around and see if your answers are correct. So you're doing G on your own. I'll give you guys like 2 to 3 minutes to do it. All right.
I think I got it right.
So we're gonna FOIL. So guys, if you wanna the correct way or understand this more, we're gonna FOIL. Basically, we have to do it 3 times because we have 3 terms. So the first one I'm gonna use is x squared and multiply that by everything in my second bracket. So I get x squared times 2x squared gives me 4x or 2x4. Remember when we multiply exponents with variables, we add the exponents together. So what's x squared times x? X squared times x. X to the power of 3. And then x squared times -2 is -2x squared. Now we're going to go with my next term, which is my -3x. And I have to multiply it by everything in the second bracket. Cubed is 3. So can someone tell me what -3x times 2x squared is? Ashton. -6x cubed. Yes, Cynthia?
Why is it cute? Is it because there's like an invisible one?
Yeah. So whenever x doesn't have a power, that exponent is automatically 1. So now my next one is -3x times +x. What does that give me? -3x times x. Yep, -3x squared. No.
Okay, wait. I think I got it.
And then my last one is -3x times -2, which gives me +6x.
Yeah, I got that part.
And now we have to do our last one, which is take the -1 and multiply it by the terms in the second bracket as well. So what's -1 times 2x squared? Yep. What's -1 times x? -x. And -1 times -2? +2. So now what do I have to look for? Like terms. So does 2x4 have any like terms? No, so you just leave 2x4 by itself. How many like terms does x cubed have? So I have +x cubed and I have -6x cubed. And when I subtract those from each other, I should get what? -5x cubed. Now x squared has how many like terms, Jade? Yep.
Does the cube always stay there?
The cubed always stays there. So whenever you're adding like terms, the variable and the exponent stay the same. You don't change them ever. So how many like terms does x squared have? 3. What are they? -2x squared, -3x squared, and -2x squared. So what's -2x squared minus 3x squared minus 2x squared? Yep, there we go. And how many like terms does my x have? 2. So what's 6x minus x? So plus 5x. And then plus 2 is by itself.
Okay, wait. I don't know why I was confused.
Yes? Because I get +6x minus x. Any questions? Yes, Elisa? Yeah. Anyone else have any questions before I move on? No, we're good? Yes?
So when you like when you subtract and add the x squared, you just disregard the.
You just leave the variable as is. Just add and subtract the numbers.
No hand-eye coordination whatsoever.
So any other questions, guys, before I move on?
Would you do the same thing you did for I as you did for E?
Pardon?
Would you do the same thing for I as you did for D?
For I? Well, let me see what I is.
No.
No. I is a bit more complex.
You would do D, right?
Yep.
Oh.
All right. So we'll do I and J. All right. So I is 4 times x squared minus 3xy minus x plus y squared minus 2 times x minus y times x plus y plus 5. That's a lot of stuff. Okay. So what I suggest you do is do one thing at a time. Okay. So what do you guys want to start with first? We'll distribute the first one first because, why not? So we're going to take the 4 and distribute it into my first bracket. So what does that become? Okay. What's my next term? Minus 12xy. Okay. So we did this part. So this guy is done. Now, when I have a whole bracket squared, how many of those brackets do we have?
2.
2.
So we're both of those values.
You guys know how to do it the short way? Yeah. I'll show you guys the short way. So there's a faster way of doing x plus y squared. Okay. So I'm just going to take numbers a and b. So I'll do it up here.
Y.
No.
So x squared plus y squared.
Close. You're missing one term. So when we have a bracket all squared, what we can do is we can take the first term, which is a, and we can square that. To get my middle term, I have to multiply a and b together and multiply it by 2. And my last term is just taking my whatever b is and squaring it. So in this case, what is my first value here, x or y? X. So if I square x, what do I get? X squared. Now my middle term is I have to multiply x and y together. So what do I get? Xy, and I have to multiply it by 2. So what's my middle term? 2xy. And what's my final term? Y squared. Good. Now, the next one is more easier. Yes, Jade. Yeah, you always multiply the middle by 2. Now, the next one, what do you notice about, do both brackets have x and y in the next pair? Not really. What do you notice about the operation of each one? Okay. So when you have two brackets that have a different operation, but the same variables, all this comes to is just squaring the first one and subtracting the second one squared. That's how it would simplify into. The reason being is if I FOIL it, I would get positive AB and then minus AB. And when you take a number and subtract it from each other, you get 0. So I'll FOIL this one and show you guys the long way. The long way to show why this is the way it is. So let's take these numbers again. So I'm going to FOIL. So A times A gives me what? A squared. A times B. Okay. Minus AB, sorry. A times negative B is minus AB. What's positive B times A? Or AB. And what's positive B minus times negative B? Minus B squared. So what do you notice about the two middle terms here? So it just becomes A squared minus B squared.
I'm so lost. Okay. Yeah, exactly.
So with that said, what is x minus y times x plus y? It would just be x squared minus y squared plus 5.
Oh, yeah.
So does everyone get it, or does anyone need clarification on something?
Okay.
Okay. So based off what I have here, is there anything I need to distribute? And what else? Yeah. So when I have a negative outside of the bracket and I put it in the bracket, what happens to all my signs? They all change. So it becomes 4x squared minus 12xy minus x squared minus 2xy minus y squared. Now I have to take this negative 2 and distribute it into my x squared minus y squared. So what does that become? Mm-hmm.
Plus 2y squared.
Yep, plus 5. So now what do I have to look for? Okay. So let's start with my x squareds. How many like terms does x squared have? 2. More than 2. 3. So what is 4x squared minus x squared minus 2x squared? Say it? Yep, it's just x squared. Now let's look at my xy's. How many like terms does xy have? 2. So what is negative 12xy minus 2xy? Say it louder. Minus 14xy. And how many like terms does my y squared have? 2. So what's negative y squared plus 2y squared? Someone said it. Positive 1. So positive y squared, and then my 5 is by itself. So if you want, after the lesson, you can come up and I can clarify this more.
Okay, I'm gonna be honest. I got lost once we got to that, and we started getting A and B involved.
So J is the same thing as what we did with x minus y times x plus y. So you guys can do J on your own. I want to do this word problem first. So I want to write a simplified expression for the area of the shaded region. So who can tell me how we're going to start this question? How am I going to find the area of my shaded region, which is the red part over here?
The formula for area.
Yep, Brooklyn?
So you find the area of the whole rectangle and then minus it with a little.
Yep. So we're going to find the area of the whole rectangle, which is given by the dimension 4k plus 6 and k plus 4. So area of the big rectangle is going to be 4k plus 6 times k plus 4. So I want you guys to FOIL and tell me what the area of the big rectangle is going to be. Area big. I'll make it nicer. Emma?
4k squared plus 22k plus 24.
Yep. So the area of the big rectangle is 4k squared plus 22k. plus 24. Now I need to figure out the area of my small rectangle. So that's given by 5k minus 7 times 2k minus 3. Yeah.
Are we solving it now? Okay. So 10k squared
Okay.
minus 15k minus 14k plus 21.
Okay.
And then it's 10k squared minus 29k plus 21.
All right. So the area of my small rectangle is 10k squared minus 29k plus 21. Now, if I want to find the area of the shaded region, what do I have to do with the area of the big and the small one? Olivia, subtract. So shaded area is equal to, so we take our expression for the big one, which is 4k squared plus 22k plus 24 minus 10k squared minus 29k plus 21. So because we have that negative outside of the bracket, what happens to everything on the inside now? They all change.
So the negative
Yep. So it becomes 4k squared plus 22k plus 24 minus 10k squared plus 29k minus 21. So now what are my like terms? Jade. Yep.
What if you what if you put the brackets in something else?
What do you mean the second one?
Oh, actually, the brackets are there.
Yeah, the brackets are there. Okay, so what are my like terms, Brooklyn?
4k squared,
Mm-hmm.
take away 10k squared,
What does that give me?
negative 6,
Negative 6k squared. Perfect. What's my next pair?
22k
Mm-hmm.
plus 29k,
What does that give me?
51k,
And last,
24,
okay,
take away 21,
which is?
3.
There we go.
I was just thinking
Okay.
that when you said yes.
So what you're gonna do is whatever examples we didn't do, you guys are gonna do on your own. And then if you have any questions about the lesson, just come and ask me and I'll clarify stuff for you. So you have the rest of the period to do those examples and to do some of the work in the textbook. But that's pretty much the lesson for today.